Yes, right now.
Okay, so this is unit 8.5. And for the homework, we're doing the even ones from 65 to 75. So let's first read the question before we try to answer it. It says rationalize each denominator. Assume all the variables are positive. Don't worry about this part here. So rationalize each denominator. What do you notice about each denominator? What does it have? What does each denominator have that's remarkable? So each denominator here has a radical.
Radical.
One of them. So to rationalize the denominator, it basically means you get rid of this radical from the denominator. This radical, or in this case, two of them. So to rationalize basically means to get rid of the radical, but you can't just ignore it and erase it. You have to do something to kind of keep the fraction, the ratio the same. You gotta get an equivalent fraction to this, similar one, but without the radical. So let's see how to do that. Let me open the whiteboard. Share. Okay, 8.5. And the question we're doing is, we're gonna do 66. Question 66, so you're doing 65 for the homework. And the question says 6 over. Okay, so the question is rationalize. Okay, so the keyword is to rationalize. Again, we mean you want to cancel, you want to get rid of the radical from the denominator. So basically to get rid of this radical, this denominator from the denominator, we need to multiply it by itself. We're going to multiply this by itself, but we're going to switch the plus into a minus. So we're going to write the fraction again. Okay, and then we're going to times it by itself. And same time, we're going to change actually. We're going to change this plus into a minus. Everything else, the other numbers stay the same. And we do the same thing at the top. We get a times the top by the same number, so we can get an equivalent fraction. Okay, so you write the fraction again, multiply the denominator by itself, basically this, both top and bottom, and then distribute. Once we distribute and multiply, we're going to see that there will be no radical in the denominator. It could still be here at the top, but it's fine. We just can't have it in the denominator. So let's distribute this. So 6 is going to multiply by both of these. 6 times 5 is 30, minus 6 times radical 2. What is 6 times radical 2? Everyone, what's 6 times radical 2?
Just 6 radical 2.
It'll be just 6 radical 2 over, and we're going to distribute this using the distributive property or the FOIL method, commonly known. So 5 times 5, then again 5 times negative radical 2. Sign would be negative. 5 times radical 2 is 5 radical 2. And then radical 2 times 5 is towards positive. Finally, radical 2 times radical 2. First, multiply the signs. The sign is a negative. What's radical 2 times radical 2?
It's 2.
Will be 2 later, that's right. Will be radical 4 for now.
Professor,
Yes, go ahead.
we have like a definition that says one.
Yes, we have that formula for a squared b squared, right?
Yeah, this one.
But
I just
prefer
use
to do
this
it.
one.
Yeah, I prefer to do it this way because not everybody remembers that formula. So you're talking about squared or the opposite of it. We gotta get to that. You can use that.
It's not false if we do like
No,
just
absolutely,
directly.
absolutely not. But not everybody remembers the formula, so you can always distribute. You can do this.
Yeah, this is a property.
Yeah, but that can be a lot complex here for some people, so I prefer to do it step by step. But you can use this if you want to use it too. You could just say 5 to the second 25 minus 2, which is 23, right? Could do that in one step.
Yeah.
Okay, so
Thank you.
that will lead to the same thing. But here, I wanted to show you something interesting about this. Now we're going to try to simplify a little more. We can't subtract here because this one doesn't have radical, this one does, so it stays the same. If you look at the denominator, tell me what happens here now to the denominator. Everybody? You're going to try to
Plus 2 square root of 5 is
Simplify. Simplify them.
What exactly simplifies here?
4. The radical 4. We get 2.
Okay, we can do that. Well, okay, first of all, we have 25 stays the same. What else after 25? These two will turn into 2. What else?
those two should cancel out, but I think it's plus 5 square root of 2.
Exactly, so these two will cancel out. That's the reason why we switch the signs here. Okay, that's the reason we switch the signs so the middle terms can cancel out. And that's basically how you get rid of the radical from the denominator. So that's how you rationalize. So once these two cancel out, those are the only ones left with the radical. They're gone because they're opposite. Actually, there's a mistake here. They should be
5, right? 5.
Should be 2, right? Should be a 2, or this should be a 5.
5. Yeah, this is 5.
Radical 2 times 5 would be 5 radical 2, not the other way. We may fix that. They have to be exactly the same, otherwise they won't cancel out. So 5 radical 2. So these two are opposites, they cancel out. And now we can simplify this. Radical 4, that's radical 4 is
2.
2. Okay, simplify a little more. Minus 6 radical 2 over 23. And you always try to simplify this, even though we have a common factor here. Okay, even though we have a common factor. What's the common factor between these two?
6.
It is 6, but 6 doesn't go into this. So it won't help if you factor this, because 6 does not go into 23. So basically, we can consider this the final answer. As you can see, we no longer have a radical in the denominator. Okay, that's basically what we mean by rationalize, and we're done. Rationalize, it looks like this. It's okay to have a radical in the numerator, that's not a problem. Okay, so basically the rest of them are pretty much the same. Just multiply by, we call this the conjugate. So when you have something like this, when you multiply it by itself and you change the sign, we call this the conjugate of this. Again, don't forget to change the sign, otherwise these two will not cancel out. You will end up with the same sign and these will add up to a new radical, so you don't want to do that. Okay, does that make sense to everyone?
Yes.
All right. By the way, if you have, let me do another example. You may have something similar like this. Let's say radical maybe 2. So when you have a radical by itself, without anything like this, plus or minus, how do you get rid of this radical from it? How do you rationalize this?
Just make it 2 radical 2, upper we make radical 2. Like we
That's right.
multiply radical 2 over radical 2.
That's right. So if you have one radical by itself, just times it by itself.
Yeah.
Also, do the same thing at the top. And then simplify it. So 2 radical 2 will be 2 radical 2. And this will be radical 4.
And
Which
2.
is basically 2 radical 2. Okay, radical 4 will be 2. And what happens next?
2 and 2 goes, it stays radical 2.
Right. Just end up with this by itself. Okay, these are the same. This number and this number are the same. They're exactly the same. They're equal. But this one looks much simpler than this one. That's the reason we rationalize.
Yeah.
Basically, when you rationalize, we can solve another question for rationalize and simplify. So to when we rationalize, the purpose is to get the expression to be less complex, as in here, for example. So if it's one radical multiplied by itself, if it's something plus something or minus something, times it by the conjugate, distribute and simplify. Yes, go ahead.
Professor, I have a question. Hello?
Go ahead. Go ahead.
Yeah. You know the radical with the power 3 and 4. Actually, I can't get to understand that. Like, I need some more explanation. When the radical has not 2, it has 3 and 4 in the side. You know.
Sure.
The
Okay.
power. Yeah. Just examples about that.
All right. Index of radical.
Yeah.
Everybody, please pay attention to this. This is very important. So basically, when you say, start with the radical. So when you say, for example, 3 to the second, we all know that's 9, right? 3 to the second is 9. But to go back to 3, we do the radical or the square root of 9. So we say the square root of 9 is
3.
So we go back, we do the square root. And the index basically is the power here. So the index of this radical, we don't usually write it, but if you don't see an index, when you say, for example, square root of 25, we mean radical index 2 of 25, which is 5. But it's not always, the power is not always 2. It could be any number to any power. For example, you could have, I don't know, 2 to the third, for example. Well, let me use a different example. Maybe, let's say 5 to the third. What's 5 to the third? It's 5 times 5 times 5, which is?
45.
That's right, 125. Now, if you want to go back again from 125 to 5, what do? We get the radical of 125, right?
To 3.
What's the radical of 125?
5.
Be 5. What's the index of the
But
radical?
this is 3, yeah. This
We should write 3.
That's right. So the power here is basically the index of the radical. Okay? So because the power could be 3 to the second, could be 5 to the third, could be any power. Let me give another example.
But when we do like plus and we multiply or we subtract or we add, like what is the rules? Or it's gonna just stay the same? Can we just subtract the power 3 from the power 2, or we can't just simplify it? I don't know. Like when you add or you subtract, what's the rules?
Well, when do you?
Like when you take power 3, like 125 power 3, radical power 3, like you add something like with the same index. Yeah, yes, we can do it. But when it's not the same index, can we just simplify and do the operation, or we can't do it at all?
Okay, so for example, you have 2 radical, let's say, maybe 3 here, and maybe 4. And you have maybe 5 radical 4 and 3. Can we add these two? Can we add them?
I think we can do it because they are almost the same. But if the other one is 2,
Yeah.
Can we simplify the 4 and 0?
Okay, so let me go over this. So when you add or subtract radicals, first you want to check you must have the same number here, what we call the radicand, and also the same index. If they're the same, it has to be exactly the same, then you can add them. For example, this is like basically like 2 of something plus or minus 5 of the same thing. In this case, we can combine these. That's basically either 7x or negative 3x. In this case, let's say 7x if we are adding. But if they're different, we can add. So this will be 2 plus 5 and radical for index 3. And combine them into this. But if they're different, for example, if you have, let's say 5 radical 2 plus 8 in the cubic root of some number, in this case, we can't add 8 and 5 because these are not the same. What is the index of this radical?
2.
The index is 2. Basically, this is like adding 5x and 8y. We can't add 5x and 8y because they're not the same. Same thing here. These are unlike radicals. We can't add them. Okay.
All right.
But
Yes.
for multiplication, you can, let's say you have 8 here times 2. So the index of these. Shaba, is your speaker on? Can you turn the speaker off, please? Because I can hear myself back. Okay, thank you. But in this case, when you multiply, you just have to have the same index. The index here is the same. So this will be 8 times 2, which is 16, which is, so radical 16 will be
4.
Would be 4. That's right. For multiplication, you just need to have the same index, not necessarily the same radicand. But with addition and subtraction, you have to have the same radicand, which is the number inside, and also the same index. And the radical could be any whole number basically as an index. I mean, it could be anything from 2 and up. Okay, so let's say, let me give you another example. So what is 2 to the 4th?
16.
16. That's the exponential form. Let's write this in radical form. How do you write this in radical form? Basically, you want to go back from 16 to 2. So what do?
So 16 radical to 4.
So radical 16 is equal to, what's the index?
Put a 4, index 4.
That's right. So,
and the answer is this 2.
That's right. So radical 16 is 2. And the power here is basically the index of the radical. So this is what we call exponential form. So another way, another form of writing this expression is in radical form. Okay, which is basically this. So this basically are equivalent expressions. They're just written in 2 different formats. Just like, for example, saying, I don't know, for example, 8 times 2 is the same as 10 plus 6. They're both 16. They're just written in 2 different forms, but the amount is the same. Think of it that way. So radicals and exponential expressions are equivalent. One of them is the opposite of the other. So this one, you go here, you do the exponent. But if you're going to go back, you do the radical. So the index could be any number, 2, 3, 4, 5. If you don't see one by default, if you don't see one, that means it's invisible to another.
Professor, for my understanding, the easier way for me to understand, like you put the radical 16, right? I put 16 and then put the brackets and then power to the 1/4. I think it's much more easier to understand, because later on you could power both sides to delete the radical 4 on both sides if in case you need to work on it. So I guess I put bracket first on the 16 and then power to the 1/4.
Okay, you can do that. You mean, so
I guess it's much easier to simplify later on.
you want to do 16 to the power 1/4, right? Like this?
Yeah, I think it's much easier for me to work on the later
Yeah,
on.
that's right. You can use that if you prefer to use that. That's fine. So basically, radical, I mean, the power 1/4 is basically just radical index 4. That's fine. You can use that. Yeah, same way, square root of anything is basically power or power. Square root or radical index 2 is basically power 1/2. So if you have, for example, 25 here, what is the square root of 25? You know, it's going to be 5. Or you can put it here too. You can say 25 to the power 1/2 is also 5. So radical index 2 is the same as power 1/2. Or like you said here, 1/6, basically 1 over the power, whatever the power might be, is 2. Same thing with the cube. So the cube of a number is the same as, of any number, is the same as x to the power, what power? 1 over 3.
3.
But don't worry about this part here. Don't worry about the part here. It's just another way of rewriting radicals as powers. But this is the important thing you need to keep in mind is this. Something like this or this. So we can switch between expressions and radicals, exponentials and radicals easily, just like this. Okay, any questions about this, everybody? Does this make sense to you?
Yes.
Okay.
All right.
Everybody else? All right. Any other questions, everyone? Still have some time. So again, like I said, we're gonna have. I'll post the final review sheet sometime soon. Let me see actually if you can find it right now, and then I may post it. Let me see.